graph rates and pull rates on a coordinate grid. Coordinate grid. So, with that in mind, we're going to go ahead and look at this. This is kind of piecing together a lot of the information that we've already learned this unit with the real world application. So a lot of times in the real world, we want to find a way to deal with rate problems, deal with the grids, deal with graphs, and use graphs logically, so on and so forth. So we're going to be determining a relationship between rates and the graphs of said rates today. The first problem I'm not going to do the way we're going to do the rest of the problems. We're going to use it as an opportunity to explore the relationship between rates and their graphs. So I'm going to think about this first as an XY chart. It says Mickey goes to the store to buy apples for $2 per pound. Plot this relationship on the coordinate grid below. Now, looking at the coordinate grid, we need to make sure that we understand what X are and what Y are. So the first thing that we're always going to do in these problems is we're going to look at our coordinate grid, and then we're going to look at our units for X and look at our units for Y. What are my units for X in this problem? What are my units for X? Anthony? Pounds, right here. Coming right along the x-axis, it tells us that this is pounds. And our units for Y, Jacqueline? Dollars. Coming along our y-axis, we see dollars. So, we're going to think about this. If I'm saying X is 0, that's saying I'm buying 0 pounds of apples. According to this situation, if I buy 0 pounds of apples, how much will I pay? Good, that makes sense.
Sure does.
I would be really upset if I went to the store and I bought 0 pounds of apples and they said, Mr. Boots, you owe me $5. All right. If I bought 1 pound of apples, how much would I pay?
$5.
So that's the 0.12. If I bought 4 pounds of apples, how much would I pay? $8. If I bought 2 pounds of apples, how much would I pay? Español es bueno, no? All right. So what we can see here is that as we're graphing this rate, this seems to be plotting a... What shape is this? Are these points seeming to getting us in? A line. So what we can see is that when we graph rates graph as a line. Now, there are some specific things that we should recognize about this line. Well, what 2 things do we know to look for when we see a line? What's the main thing that we always know to look for when we see a line?
Linear equation.
Okay, linear equation. So we don't have an equation for this. We could write an equation for this. Yeah, so we're always thinking about, when we see lines, we're always thinking about slope. So let's go ahead and find the slope of this line that we've graphed. So I am looking at, I'm just going to pick 2 points here. I see that I'm rising 1, 2. So my slope is equal to rise over 1. So my rise is 2, and my run is 1. And if I think about that in terms of units, my rise is how many, or my rise is in telling me how many units? Dollars. And my run is telling me I'm running how many pounds. So it looks like my slope is telling me it's $2 for every pound. That's the rate. It's given to us in the problem. The key piece of information we need to walk away with after doing this problem is understanding that a rate, when graphed, is always going to be the same as the slope. Or the slope of a line is always a rate. So, with this idea in mind, we can always graph rates that are given to us, or we could use slopes of lines that are already graphed to help determine rates. Andrea. Rise over run is always going to be slope, which is always going to be equal to a rate. All right, Kevin.
Does it matter if it's positive or negative?
It would matter if it was positive or negative. At this point, we're only going to be graphing positively sloped lines from real-world rates. We're going to learn about some negative rates way after CST. That's going to be the last thing that we're going to do. All right. Next one says, Jamal goes for a walk. Jamal being a he, walks 10 miles in 2 hours. Plot a line on the coordinate grid that shows the relationship between the number of hours he walks and the number of miles he walks. So, using this idea that we know the rate is always equal to the slope, we can use this idea that we know that the slope of a line is always the same thing as the rate. But really quickly, I want to think through a little bit about my slope first. I know my slope, if I graph it on this coordinate grid, it's going to be my rise over my run. And using this coordinate grid, the units of my rise are going to be what? Miles. And the units of my run are going to be hours. So we have to be really careful here. Sometimes, remember, there's two ways to write every rate. So sometimes the way that they give us the rate in the problem will actually be the opposite way that we want to use it for our slope. That's why I'm checking in on my units right now. Because it's very possible they could have said, in 2 hours, he walks 10 miles. In which case, if you had written 2 over 10, that wouldn't have made any sense, because you would have had 10 hours and 2 miles, as opposed to what we're really supposed to have according to our coordinate grid, which is 2 hours, 10 miles. So that tells us that we need to graph 10 miles, 2 hours. That's our slope. Now, obviously, if he's not spent any time walking, he's gone how many miles? 0. Okay, so our starting point's here. Now, I want to rise 10, run 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, run 2, right?
No.
Why not? William.
Because it's not like that, because it's not like 1, 2, 3, it's like 2, 4, 6.
Excellent. So what William is recognizing is that there's a difference in our scales here. This is also very important to always keep an eye on that scale. If I want to rise 10, I'm counting by 2. So I'm actually going 2, 4, 6, 8, 10, run 2, 1, which is 2, 2, 2 at a time. Okay? So that tells me my first point is here. If I want to rise 10, run 2 again, it's 2, 4, 6, 8, 10, run 2. Counting by 2s, that's 2.
Oh, yeah. Oh, is that just 2 lines? 2 dots at least? Sure.
So let's move on to the next one. Now the next one says the line represents the pounds of bananas that can be purchased with a given amount of money. What is the rate in dollars per pound? So if it's asking us what the rate is, we again, our big key thing here today is that the rate is equal to the slope. So all I need to do is find the slope to give me the rate. One thing that I do need to check on, always first thing, is to check on my units of my rise and my run. What are the units of my rise? Jacqueline? Dollars. And what are the units of my run? Naomi? Pounds. So, I'm looking here, I want dollars per pound. That's good. Sometimes it may ask us for the rate to be written the other way that our slope is going to give it to us. So this one's okay though. All right, I'm going to pick 2 points. Remember, it doesn't matter what 2 points you pick. It's always going to be the same slope no matter what 2 points you pick on any given line. So I'm going to count my rise. 1, 2, run 1. Right? Right? No?
Yes. No.
No?
I know why. IDK.
Why not? Michael?
IDK.
Why would my rise be 2 and my run be 1? Bijan, why would my rise be 2 and my run be 1? It's not going by 1. So again, he's looking here at this scale. My rises is going in increments of 2, and my run is going in increments of 5. So as I'm counting my rise, I'm counting 2, 4, and a run of 5. Because we're counting by 5s in the x direction. Always got to pay attention to your scales. It's an important piece of information. They love to throw that mess at you on the CST. And if you know the scale, it's super easy. But if you count by the wrong value because you never look at the scale, you will sadly get it wrong. So our run here is 5 because we're counting by 5s. In a problem like this, I want you to get used to also finding the unit rate. Remember, to find the unit rate, all you have to do is divide. So we're going to take the top dog, we're going to put it in the house. We're going to get $0.8 per pound. The reason I'm asking you to do this is because sometimes they're going to ask you for the rate in fraction form. Sometimes they're going to ask you to give the rate in terms of its unit rate. You just need to be able to know how to do both depending on the answer choices that are given to you. Yes, sir?
Once you get 0.4, if you go up by 10 and you go that way, 4 or 5.
So my runs are counting in 2. So 2, 4.
Oh.
Okay. Good clarification. All right, last one. They're not actually giving us a line here. They're just giving us points on the line. I'm going to go ahead and graph the line. The reason I'm going to graph the line is it just makes me visualize better what's going on. And sometimes it'll help me catch points that maybe they didn't graph that would be useful to use. All right. The next thing I'm going to do is, I see this is looking for a rate of apples to oranges. I'm going to go ahead and write my slope. It's equal to rise over run. And I'm going to check the units on my coordinate grid. The units of my rise are oranges. And the units of my run are apples. So this rate is actually going to give us the rate of oranges to apples. The question asks us for apples to oranges. Just remember that's the difference between the different ways you can write that rate. So once we get our slope, we're actually going to need to use its reciprocal to answer the question. Okay, so I'm going to count my rise. 1, 2, 3. And my run, 1, 2. So this tells me it is 3 oranges to 2 apples. But to answer the question, we want apples to oranges, so we have 2 apples to 3 oranges. Okay, does everybody understand why I flipped that over?
Yes.
Okay. Winta, or anybody else who is showing me no that I just didn't turn around and see. We're just looking at the units that were given to us on the grid. Our slope tells us it's supposed to be, we're going to find oranges over apples. But if we read the question says, what is the exchange rate for apples to oranges? So that's why we flipped it over. So we just had our exchange rate the correct direction for the question. All right. Any other questions? All right, let's hit some key points. Kevin, key point number 1.
It doesn't matter if it's negative or positive, right?
It does matter if it's negative or positive. We're just not going to see any negative ones today. Renee.
Check the what's it called? The numbers counted by for the y and the x axis.
Okay, let's use some language for her. She's looking for the numbers that we're counting by. Where do we look for that? What is that called on a graph?
Slope.
What is it called for on the graph? The part that tells us what we're counting by. On the axis, we see the, what are these numbers?
The y axis.
False. This is called the scale. This is information that you need to know. The scale tells us what the increment is. So, Renee is saying, check the scale. To see what your rise and run are counting by. I hope you're writing down this key point because I don't want to get to your work later and then have to tell you, please go look back at key point 1. And then you say, I don't know. Check the scale to see what your rise and run are counting by. That's super important. Joseph. Read the question carefully. Why are we reading the question carefully? What was the thing that was in the question that kind of messed things up? The order of the rise and run, or the units on the rise and run. So always check the units. Oops. Always check the units on the coordinate grid. For your rise and run. Always check the units on your coordinate grid for your rise and run, and you're wanting to compare that to the information that's given to you in the problem. And then there's one third key point, which is the big overall piece of information that we learned today about the relationship between a rate and its line. What did we learn about a rate and the graph of a rate? Kirby. The rate and the slope are the same. So this is the big overarching thing we learned today, that the rate is equal to a slope of the rate, and the slope conversely is also equal to the rate. So if we're given a rate, we're also given the slope. If we're given a slope, we're also given the rate. Okay?